Hello everyone, welcome to the topic Relations and Functions. Here we discuss composition of functions, FOG, GOF and inverse of a function. Consider f from r plus 2 close to open interval 4 to infinity given by f of x is equal to x square plus 4. Show that f is invertible with the inverse f inverse given by f inverse of y is equal to root of y minus 4, where r plus is the set of all non-negative real numbers. Here, the domain and codomain, not complete real numbers as it looks. The domain is only r plus, that is non-negative real numbers. Hide all the negative numbers. Only from 0 to infinity can be used in the domain. And the codomain says the numbers from 4 to infinity only need to be used. 4 to infinity, 4 to infinity. So this is domain, this is codomain. These numbers are not to be used. And the rule is given, f of x is equal to x square plus 4. We need to show it is invertible. When do we say a function invertible? A function is invertible when a g exists from this codomain to domain in such a way that GOF is identity function and FOG is identity function. This time we are given a reverse rule already. F inverse is root of y minus 4. We need to just verify this itself is the inverse. Let's go ahead. Let us take a y in the codomain. It is in the range of f now. Let's take a y. Now, since it is in the range, this y can be written as x square plus 4 for some x of this domain. Now from here, let us see how to get the x back from this y. That we will be able to solve from here. Y minus 4 is equal to x square. So x is equal to root of y minus 4. This is the rule by which we can go back to the x from y. The rule by which you go back is supposed to be the inverse actually. But don't simply guess it. We need to prove this rule is the inverse. That's what we are asked to prove. This rule is the inverse. You prove it. How? By showing this function satisfies this condition. So let us take this as the g function. Take it as g function, root of y minus 4. It was already given also, and we have now calculated it also. Still it's not enough. We need to verify this is the g function which would satisfy this definition. So let us calculate GOF and FOG and see for ourselves whether they are equal to the identity functions. Let's take GOF of an element x. That means g of f of x. That's what the composition of functions say. G of f of x. And what is f of x? F of x is x square plus 4. Place it here. So g of x square plus 4. Now how do we calculate g of x square plus 4? G function says take the square root of the element minus 4. And the element now is whole x square plus 4. So let us apply it in the g function. That gives us root of the element minus 4. Root of the element minus 4. Element is x square plus 4. Place it here. That gives us simplification. X square plus 4 minus 4 is x square. Under root of x square is x. So we got GOF of x is equal to x itself. What does it mean? GOF of x is equal to x means GOF is identity function. Now let's see, what about FOG? FOG of y is equal to f of g of y. First you place what is g of y? Root of x minus 4. So we need to calculate f of root of y minus 4. Now how do we evaluate it? F rule says square the element and add 4. And what is the element you have? This one. So to apply that in the function, we will have to square it and add 4. That is the rule. Square it and add 4. So we will square this root of y minus 4 and then add 4. Place it. Root of y minus 4, when you square, that becomes y minus 4. And then when you add 4, it is equal to y. So we could get FOG of y is equal to y itself. That means FOG is acting like identity function. F of x is equal to x is called identity function. So FOG also is identity function. Both conditions are satisfied. So from these two together we can say this g that we took itself is the inverse. This gy is the inverse of fx. Therefore, f inverse y is equal to root of y minus 4. This is the f inverse y. The g that we started with is nothing but the inverse of this function. We got the inverse of this function.